I made a short video that way you have this one.
Good afternoon all and welcome back after lunch. Welcome to the Industry 4.0 round table, and as somebody said, but the table is not round because then they will be facing the other way, right? So we want them all to face the same way. I'm Gerrit Zaayman, VP of Scheduling and Digital Transformation. So Industry 4.0 is a hot topic right now, right? So almost every conference for the last year and the next year or two has got Industry 4.0 as a theme, a topic or something. Almost everybody that manufactures some other piece of electronic equipment somehow says it's got something to do with Industry 4.0. Software vendors that builds any software that you can use anywhere in a business somehow frames it as Industry 4.0, including Simio, right? So let's look at the agenda. So perhaps from a discussion perspective today, I'm sure we've got a very good panel, but I'm sure we won't be able to answer all the questions. Perhaps get some discussion going specifically around simulation and its use within the Industry 4.0 environment. The agenda is fairly simple. We'll do some introductions, we'll have a panel discussion, and a wrap-up at the end. So let's start with the panel. So the first member is Jeff Smith. He's our academic sort of member on the panel from the Auburn University. And here's, so I'm at this age where I need this, right? So Jeff has taught simulation at graduate and undergraduate levels, consulted in simulation-related projects for 30 years, right? So I know there's some folks in this room that's not even 30 years old. So yeah, so in addition to his academic positions, he also is a founding partner of Conflection. He serves on the board of directors of the Winter Simulation Conference. He's a co-author of the textbook Simio and Simulation, and it's currently in its 5th edition, and I think it's available on Amazon, right?
It is.
So, yeah. Oh, and on the back corner. He has PhD and Masters in Industrial Engineering from Penn State, and also a Bachelor's in Industrial Engineering from Auburn. He's also a fellow of the Institute of Industrial and Systems Engineering and a senior member of the Institute for Operational Research and Management Sciences. Thank you, Jeff. Our next panel member is Sebastian Urbina. He was our very first presenter on Tuesday. He's the Director of Supply Chain Innovation at Barkawi. It's a Genpact company. They've recently been acquired by Genpact. So Sebastian has a lot of experience, 10 plus years working with 40 plus companies across a variety of industries, focusing on solving complex supply chain problems. Extensive experience in designing and implementing technology to facilitate supply chain transformation, right? And that includes the digital side of that as well. Deep supply chain science knowledge, having developed inventory optimization, profit maximizing algorithms, solve network design optimization challenges, and supply chain analytics. Expert in forecasting and demand planning, having created custom machine learning, best fit algorithms in R, and he's also worked and lived on most of the continents. Thank you, Sebastian. The next is Manuel Remehle, Principal expert process simulation at Bayer AG. So Sebastian is our consulting representative. Manuel is our industry expert. And Manuel is a chemical engineer with a strong background in computer-aided process engineering. He's with Bayer for 13 years and worked on projects involving data analytics, advanced process control, and dynamic simulation in various forms. He's responsible to align strategy and steer innovation in the area of modeling and simulation, covering chemical process development, product lifecycle management, the optimization, manufacturing processes, and facilities, as well as production scheduling. He's also the coordinator of an EU-funded research project. It's about a 3-year, 15 partners involved on integrated process control and sensing for flexible modular plants, and now also responsible for the shaping the model and simulation strategy for Bayer AG. And Manuel also serves on the customer advisory board for Simio. Thank you, Manuel. And then last but not least is Dennis Pegden, which I'm sure I do not have to introduce, but I will do so just to be fair, right? I have to be fair. So Dennis was the founder and CEO of Systems Modeling, which those of us, you that comes with us a long way, knows that was the Simon, Cinnamon Arena phase. He held faculty positions at the University of Alabama and also Penn State. He led the development of SLAM, Simon, Arena, and now Simio. He's co-authored 3 simulation textbooks and has published papers in a number of fields, including a lot of things that I don't know a lot about: mathematical programming, queuing, computer arithmetic, scheduling, and simulation. Right, thank you to the panel. Right, so now I can remove this. So to get the discussion going, I just wanted to share some thoughts. What does the industry say? What do we as Simio see if we go out in the market? And when we go to customers and prospects, a lot of the things that we typically see is they will ask us, we want to do process, supply chain design, and analysis. So that's what we all have been doing a lot of, and that sort of makes sense to us. They then say we're busy with Industry 4.0 initiatives. Now it seems that the market is quite confused as to what that means. Some people clean data, some buy more gadgets, some do consulting projects, all in this Industry 4.0. Some people say we're doing digital transformation. I'm not quite sure what happens, but to us when we get there, it seems like it's the same after than before, so I still struggle to understand what actually happened there. The smart factory is one we like, right? Because the smart factory says, if the factory is smart, then something must make the decision. What is that thing going to be? And we say, well, we think it's Simio, right? Simio might be that thing, right? And here, hence also the process digital twin. It's sort of new, it's gaining, ground. It was also just a parts twin, but now the process digital twin. And now even more, the supply chain digital twin, right? Integrated scheduling. Most places we go, as Louise said, it's spreadsheets all over the place, and it's in silos, right? It's the making, the filling, and the packing, or whatever it is done separately. So the notion of integrated planning, I think, sounds well to us. And then they say automated, right? Automated. Now that's great, right? But wherever we go, the decisions today are made by humans. Humans right to the machine level, the operator on the floor. If I walk the floor, I ask, so who's making the decision which part to process next? The operator. Right, so the knowledge about the decision is where still? It's in the heads of people, right? So to automate it is still some work ahead. So if we look at the software vendors, Simio, that they say we are going to become the leading process digital twin solution to do design and operation of complex systems. It sounds cool, right? But we will still figure out what it all means, but it sounds cool. So perhaps at the end, if Eric gives me a 30-minute commercial piece, I'll tell you what it means. So let's look at what Forbes say, and I really like this one. It says Industry 4.0 optimizes the computerization of Industry 3.0, right? Optimizes the computerization of industry. So there's a catchword in there. It's computer. Because we find that a lot of companies does not have an MES. They don't have any automation. They don't have any tracking system. So the data simply is not there to go the next step. It then goes on to say, and now into the future, as computers gets connected, all right, ultimately the decision will be without human involvement. It's almost like the self-driving car, right? It's great, we'll probably get there, right? But it's still some time before we do. So let's look at one more. PwC did some research. They went to about 50 or so Fortune companies and said, what are the top things over the next 5 years that you're going to spend time and money and effort on? And I just want to highlight a few that would be of interest to us. And that's the digital twin of the asset, the resource, to describe the filler or the mixer or the winding machine. How does it behave? How do we dictate the behavior of this machine? The next step is then the digital twin of the factory, right? Because all that a factory is, it is a grouping of these assets and then a flow through these assets based on a routing and a bill of material and so forth. The next one is the integrated planning one, right? So it surfaces again. We've got to be able to look at the process, the factory, or the supply chain as a whole, right? That's an important point. Visualization is important as well. As Louise also said, they want to see, they want to put their glasses on, virtual reality, augmented reality, or just a nice animation and see the process. I think Ian from McKinsey said, just show them the simulation, let it play out, and just by watching it, you can learn. And the last one here is this whole sort of fully automated factory, right? That's the ideal, it's sort of a lights-out factory, but that is still, there's still a lot of work before we get there. So one more, BCG said, for Industry 4.0, there's sort of 9 critical technologies that's going to play a part. So the one that jumps out to us is the simulation one, and not everybody has embraced that, right? So if you don't have simulation, it leaves a hole there. And from a Simio side, we can really help you with that. So Greer and Dwayne will take some orders in the back there for those that don't have it yet. Right? It's just a joke. So there's things like the visualization, the cloud, cybersecurity. So just think, you have a full automated factory, and a virus gets in there, and one of your machines gets a flu. Right? Soon the whole factory will be very sick. There's no humans there now that can work. We've been at a factory or a process in Switzerland last year where there's not even oxygen in the factory, right? There's no lighting in the factory. When people go in there, they go in pairs in a suit with oxygen mask if they have to go fix anything, right? So that's, it's cool, but if you stand there and watch it through the glass, it's a scary thought, right? That there's not even oxygen in there, and it's for fire and all of those things. So right, so let's get the panel discussion going, and I'm just going to start with some starter questions to the panel, and then we're going to throw it over to the audience to ask some quick questions, and given on time, I'll ask some closing questions and some final remarks at the end. Just some guidelines. Please try and keep the questions sort of short and to the point. Sometimes people give a speech before they ask the question. It's all good. You have to provide some context. I will ask the question specifically to some panel members, but the audience questions, any of the panel members can pick it up, and if more than one wants to enhance on that, please feel free to do so. And please make sure you get the microphone. Erica is there with the microphone, so just wave your hand for the microphone. All right, so let's get going. So the first question here, I want to ask to Jeff. Sorry, you're closest here. So how are simulation models used or can be used, and do you see the application if you look at the BCG graph? How will these models be used in Industry 4.0 planning system?
You want me to come there? You want to stay here? You have a microphone. Okay, thank you, Gerrit. First of all, I'd like to thank you for inviting me to be on the panel. Actually, Gerrit didn't invite me. He had Renee invite me. I suppose he thought I might turn him down, but that I wouldn't turn her down. But anyway, I'm happy to be here. And I also like to just make a quick comment before I answer the question, and we'll wind into that question, that really the only new thing about Industry 4.0 is the actual term Industry 4.0, at least on my time scale of the 30 years that I've been working here. In fact, when I was a PhD student at Penn State, we were doing many of these exact same things using Simon that we're talking about now. Of course, it was quite a bit more archaic back then, and there was a lot more of the technology that we had to develop, but the same basic concepts were there. And so to answer the specific question about where simulation comes in, when you look at the Industry 4.0 model, the picture that Gerrit showed that you've seen before at this conference, it requires having both descriptive and predictive modeling capabilities for the system. And certainly analytical software can provide the descriptive capabilities and at least some coarse prescription. But what we really need is a high-fidelity simulation model in order to incorporate constraints, production capacity requirements, resource contention, and things like that in order to provide more accurate predictive capabilities that are required for that type of integrated system.
Thank you, Jeff. The next question, I think, to Sebastian, is what do you see as the future of the digital supply chain, right? So it's the factory, but then the word digital supply chain starts to surface as well. So what would you see the future of that?
So I definitely see that it's going to move beyond the factory. The factory is just one component of what the whole supply chain looks like. When we start looking at more of a digital supply chain, we're thinking and envisioning more of a fully integrated type of technological landscape. Not just a simple, like you have the factory, the MES, or you have the TMS or the WMS. We're looking more of a single source of truth that's integrated through all the different systems. We're envisioning that it's no longer going to be just a demand planner and a supply planner and a production scheduler and a dispatcher. You're going to have a supply chain planner that's going to have the capabilities and the right tools to be able to make all the decisions with a single point of contact that integrates with all the different places that it's coming underneath. And it's through that we actually start getting inefficiencies and eventually be able to run like this crazy idea that I don't think I'm going to see in my lifetime of a lights off, like 0 people, like type of supply chain type of situation. And as we're doing this, we're able to actually capture a lot of the data. A lot of that data that is not currently being captured, which is the human behavior. What is that person actually doing? Like when there's an allocation situation, how do they decide how to allocate and who they actually communicate with? That actually happens in a disparate amount of systems, including phone calls and email. But as you start consolidating them into a system of engagements, you're able to actually generate this level of data to actually start bringing in additionally like AI, ML type of capabilities, which actually ends up feeding in your underlying model and your capability to actually improve the decision making that you're doing. And as you're moving forward, you're actually moving the people away from simply just making decisions and firefighting, but you're actually generating a system that is giving recommendations, which eventually could actually take the actions themselves. Even write up the email and say, hey, dear Home Depot, by the way, this is going to take late. We're sorry. Thank you, type of situation.
Thank you, Sebastian. Next question to Dennis. I think we see that a key element of Industry 4.0 from our perspective is the digital twin. So, I mean, discrete event simulation for manufacturing processes, as Jeff said, is not a new thing, right? So what makes the process digital twin different from the traditional simulation model?
So, you know, many of us have been doing traditional simulation for many, many years, right? And the thing that always frustrated me with that is people would put a lot of effort into building a model, sometimes months of effort into building a complex model to answer questions about the layout of the facility, and then that model would be thrown away. Right? And so the notion of being able to carry that model into continuous use on a day-to-day basis was always something I thought was a key to moving simulation forward. The challenge there is to allow that model to plug into all the real-time data that's relevant to it. And that data is typically relational, coming from the MES, the ERP. And so you really need near real-time ability to talk to complex data as part of the way the simulation model works. So I think it's hard to take legacy simulation products and plug them in because they weren't designed for that purpose. So it's really important to have modeling constructs that from the ground up are designed to interface to this complex data.
Thank you, Dennis. The next question for Manuel. So there's the factory, then there's the supply chain, but then there's the process, right? So from a buyer perspective, there's a lot of work that's been done on the process, and it's got to do with AI and self-learning, and I think the folks from Lockheed also mentioned that. But how will that AI and self-learning layer, how will that operate and feed into a scheduling layer?
Okay, so as Jeff said, Industry 4.0 is actually nothing new. Bayer has been using AI methods for more than 20 years. With regard to your question, it's actually easy. You can teach an algorithm, a model, to determine when will something happen. So you have a running process, but you have process variability, right? And to compensate that process variability, to predict when will the certain step be finished, or will there be a quality problem maybe, then you can use AI methods or machine learning in a more general sense. At Bayer we have these kind of algorithms, not for predicting the time, but for example for detecting when a batch process is behaving differently. So we have trained the models with good batches, and when there's deviation from the normal behavior, this algorithm can detect that there is a deviation and alarm the operators. And we have also quality prediction models that can predict the quality at the end of the batch, during the batch. So this might trigger a kind of rework action that has to be done. You have to isolate again the same substance, or do other work, or plan a disposal procedure, things like that. So there is an interaction between the chemical process in the chemical industry and the material flow simulation or discrete event simulation in that sense.
Thank you. Thank you, Manuel. So that was quite interesting for me when Manuel shared similar thoughts with us, is that one of the things that kills a process is variability, right? Especially if you don't know that it's going to happen, because you can schedule and plan it fantastically, but if you have a quality issue, a failure, whatever, your plan is out the window. But the sooner you know it, you can react to it, right? So by having these trained algorithms on a process level, you can now know 2, 3, 4, 5 hours in advance that you're going to have a quality issue or that you have to do preventative maintenance, and alert the scheduling system that this is going to happen, right? So it is quite an interesting feedback. All right, so now I want to open to the audience, please. So any questions? Thank you, Lauren. And Eric said we can go as long as we want, right, Eric? No. Okay.
I'm curious on your standpoint of data-enabled resource optimization. It was something that you showed on the chart, but it wasn't highlighted as one of the capabilities that you are aiming for.
All right, so you mean the PwC chart?
Yes.
All right, so that was just what PwC said is the things that people are going to, work towards. But the data enablement is like the crux, right? Because wherever we go, data seems to be, the key issue. But I would let one of the panel members pick that up.
So I think when they talk about data-enabled optimization, resource optimization, you can build an optimization model for a fixed set of resource availabilities or schedules and all of that, and people have done that for quite a long time. But I think the critical aspect here is being able to do that just from the data without human intervention. So you're not rebuilding the optimization models, you're reading that from data. And so when the data changes due to factory downtime or something like that, there's no need to do the re-optimization manually. So I think that's the key concept that they're talking about when they talk about data-enabled optimization.
Thank you. Anybody else wants to touch?
I'm not real sure what they mean by optimization there, but I think of what Manuel's talked about in terms of predicting, using data to predict quality or necessary repairs that have to take place, and learning that sooner than later as data-driven optimization of the system. You're using data to help you run the system better.
Next question. Oh, sorry, Sebastian wants to.
Another thing that I would add is the data availability. Like as we're growing and capturing more and more data, it becomes possible to be able to do this type of analysis happening. Like, yes, as they discussed, it's the whole, I do believe it's part of that whole automation, but that whole automation comes from the ability of the big data development that is actually happening and the application of it through its resource, the resource use and what you do with it, and the decisions that you automatically can make.
Next question.
Yes, thanks, Gerrit. My question is about Industry 4.0 and whether it will actually become mainstream. So with the previous, let's call it revolutions of industry, it became the adopted norm, for progress. And the reason I'm saying that, so it's not necessarily something new, but the practicality of making it mainstream has some constraints, and you yourself know, for instance, data is a problem. So, and if data is available, okay, there's still issues with it. But once you get the data, which you don't always get, at most places currently, there's the aspect of connectivity. So I'm simplifying, just a few elements that will make a digital twin solution in the end, right? But things like connectivity and then two-way communication between the different systems, and all of those types of intelligence. So there's a lot of tick boxes to be checked for a solution or a company or even a subset of industry to then, by definition, function as an Industry 4.0 company. So my perspective is, globally, specifically in the markets where we operate, I actually don't foresee, it being adopted mainstream by the majority of the companies. Only the select companies like Bayer is an example that would be able to do that. And another question is, so when we use Simio, we actually have a very, very good and advanced solution. And we can implement it in such situations, but not necessarily as definition as a true digital twin. So what would you then classify, that solution as? Because we are all, heading towards Industry 4.0. but it doesn't mean we are ever going to truly, get there in the majority of the interactions we have with our clients.
Any volunteers?
For the first part of the question, I think it's good that we have this Industry 4.0 initiative and thinking and so on, because now the companies and management especially sees there are opportunities, and they start thinking about what data do we actually need. So at Bayer, there's an ongoing discussion, okay, which kind of data do we need, how do we have to structure it so that we can use it for these kind of applications. And I would say 8 years ago, nobody was interested in collecting more data or differently. Now they are investing because they know there are opportunities that we want to exploit. And I think that that is true for many companies, that in the past, in Industry 3.0, the focus was, can we automate to have less personnel, right? Now is, can we automate the decision processes to be better in our business and not to get rid of people. And I think that's a good thing, that we now are focusing on what data do we need, how do we have to structure it, and starting pilots to show that this brings benefit.
I think there's an increasing amount of traction in terms of supply chain professionals in their understanding of where they want to take the company, and particularly the implementation of Industry 4.0 concepts. I wouldn't say there's a particular industry that's going to lead it. I think it's going to be more leaders within the different industries, whether it's in high tech or whether it's in a CPG type of situation. I think it's going to start with big companies as opposed with small companies because they have the budget. And they have all these types of investments are expensive, particularly if you start looking at IoT type of stuff. That's ridiculous. So it requires an ROI on top of it. And that ROI gets justified better when it's a larger company than it is a smaller company. So I think it's going to start more with global companies, maybe divisions within the global company as it's moving forward. I think over the last 10 years, there's been a significant amount of investment in individual planning systems or individual siloed systems that can only take you so far. And as they've already been implemented, because there's a significant number of companies that are already at that level of maturity. And if you start looking at, for example, SAP's IBP, in which they're actually trying to integrate the planning process into other sections of the company. Sorry, I keep talking to that way because he asked the question. And they're incorporating finance and marketing. They're also finding that you actually need to have that level of integration as well to the other sections of the supply chain. You can't just plan and then not be able to deliver. You need to be able to incorporate truly, properly, and effectively the capacity to actually determine your capacity to deliver what you're planning for. And that inability causes a significant amount of friction and a significant amount of problems in a large number of corporations. And it's because of those problems and those fires that are actually starting that when we've been engaging with high-level executives at global companies, it resonates. Not so much when we say Industry 4.0, because they see that as a buzzword, or we say simulation. It's when we actually show them a use case and say, yes, I know you have an available to promise date that your very expensive multi-million-dollar system is telling you that you can never execute to. And you have planners that are trying to scramble to change this back and forth, and you're running all these kind of scenarios without looking at everything back. And when you tell them that's solvable, and we could actually give you the right answer so that when it hits the factory floor, your production scheduler doesn't ignore it and does its own thing, that generates value, that resonates significantly, and that we believe is going to lead to the investment necessary to make this a reality.
Thank you, Sebastian. I would agree with that. I was, I lived through the supply chain era, where when we went to customers and say supply chain, they said, "What's that?" Right? And you always get the leaders in the specific industries that needs to be on the leading edge. They explore. Some of them are in this room, and I won't mention names. And then you get the folks that sit on the side and see, what is this thing? Does it work? Does it deliver value? So there's an adoption curve in the market, and I can really see, I agree with Sebastian, I've lived through the supply chain phase, and this message resonates better than the supply chain message at the same time, right? So I think the adoption will come. Will everybody do it? No, not everybody did supply chain. People are still on spreadsheets and. But that a large number of companies will have to adopt it. At some point, people just do it because they don't want to be left behind, right? So with supply chain, that was clear. The laggards at the end just scrambled and pay whatever they need to just so that they're not left behind, right? So these things sort of take care of themselves at some point. Next question. There's one there at the point.
Hi. I'm not too familiar with Simio's scheduling functions and what it does. From, I guess, manufacturing side, I think our company has struggled having that digital process twin or finding a software that would be able to handle that. I think that's tried to be kicked off, multiple times with different organizations over the last several years, and then it just kind of dies. And a lot of that comes from precedence constraints. So we have very detailed steps, and from critical chain, it has to be a hard constraint. We don't really want to mess around with soft constraints, but those happen on the floor, so we can never get our models to match up with what's actually going on. So I guess in this software, would it have to be a hard constraint? Or is there a capability that you could do a soft constraint, meaning, I guess, or workaround? So you may lose efficiency, but that is what happens. I don't know if that makes any sense or not.
Yeah, I think I understand what you're asking. I think it does make sense. The way we look at that, what you're talking about, soft constraints and hard constraints, is in an optimization perspective. So you move the soft constraints to the objective and just penalize. And so what you end up doing is having your hard constraints that have to be met, and the soft constraints are met wherever possible by the optimization function. And so that functionality in the Simio models that we do, that's exactly how we implement those. Both constraints from a task perspective, also from a resource perspective, to do things like setups and changeovers and operators and on shift and off shift and things like that.
What is the relationship between RPS and OPQuest in the sense of a lot of times whenever you're running an experiment, it's kind of a guess and check to figure out if you've made an improvement or what you're looking for, whether or not it meets the need date that you're trying to achieve. But a lot of times, the question we're asked by leadership is, well, what does it take to get there? What do I need to do? And with OPQuest, you can set the expression with some parameters of variables that can change. How are those two connected? I'm just curious.
Okay, so it's possible to use OPQuest as a precursor to running your plan in terms of RPS, right? So what you might have certain things you want to experiment with as parameters that you set when you run your plan, and they could range from priorities on groups of jobs to what rule is going to be used. Maybe for one set of jobs, it's good to use one rule, but for another set of orders that you're going to process, maybe a different rule is more effective. So you could, in advance, run the optimization from OPQuest and let it set the correct parameters to use in generating the plan.
Next.
Hi. Could you speak a little bit about some of the goals and tangible applications for AI and or machine learning in this discussion about Industry 4.0, because I think they're kind of buzzwords or used as buzzwords, which can muddy the actual maybe applications or goals for them.
Sure.
So in terms of machine learning, AI, and it depends on what your definition of AI actually happens. When you look at the supply chain, and there's a particular points that we've seen that it actually applies. In terms of predictive maintenance, is particularly useful, particularly when you start looking at IoT, and you have this huge stream of data of actually what's the state that is actually happening, and how you could actually preventively see what's actually going to break down and when it's actually going to break down based on a wide variety of data. So that's one location. Another place that we're actually looking at it is in demand planning. When you're actually looking at forecasting historically, and I'm sorry, we're going away from simulation, but when you look at forecasting, traditionally you're only seeing your individual time series associated with it, and that's how I would say 99% of the companies do their own forecasting, simple moving average type of situation. We've seen evolution in like demand planning 2.0 tools under which you're actually generating a huge database of indexes of external factors, whether that's like GDP, interest rates, or specific things like tourism arrivals. And then you have, there's a couple of data sets that are out there and you can consolidate them. And then you do a ML AI test to see which of these indexes actually provide some predictive value to your ability to actually forecast. So you might have 2,000 indexes, but for each individual product or family of products, it might be one or two products that actually, or indexes that actually affect it. For example, one of the cases that we've seen is we were working with a lighting manufacturer. They did dimmers. And we found that construction permits were a leading indicator for how many dimmers they sell. When you actually find it, it actually makes all the sense in the world, but finding it is a lot harder. As well for another one, it was one of the, they did headlamps and they also did electricity systems. We actually created an index based on the number of government incentive programs and linked that up with a couple other things through AI ML. As well, we've also worked in terms of, and we've seen it, for engineer to order, where you start getting sales information from them to actually do a ML model to be able to see what you're doing. So that's another area where AI ML actually applies. We've actually also seen it in, and we've worked through it in terms of natural language processing. So at one, and I'm sorry, we're talking more of what we've done because that's what I have a little bit more experience in. We took every single contract for one of our clients in terms of what do they actually bill for logistics, so transportation contracts. Some of these contracts were 20 years old. They were not systemized. They were just kind of like PDF files. And we processed them, read them, understood what they were, understood what their terms, and then at the same time, we actually saw what are all the bills that they were getting. And there was a comparison of what are the terms, what are the bills, and we were finding like pennies of difference in a bunch of different things. But when you have a large company, those pennies add up to like tens of millions of dollars. That's, I mean, it's something that we're just going away and nobody was actually looking at them until you actually start applying AI ML type of characteristics to it. Another one I was mentioning before in terms of like the sentiment of what people actually end up doing when you actually have an allocation problem or when you can't actually deliver. We do see that once that data set gets created, AI ML capacity gets implemented there to try to be able to understand what's the best step that should be done. Granted, this requires a significant number of data sets, so it's going to be a couple of years worth of data before a company can actually apply them. But we do see that once you get that, you start getting recommendations of what you should be doing to be able to apply it. I don't know if that's kind of like enough, or you want me to, like, if I should keep going in terms of like more and more examples.
Yeah, I have a very good example for that. And first of all, Industry 4.0 is not about simulation only. It's actually, it covers the supplier network until the end customer, right? So that's the idea, also to have that connection. And Bayer has developed an application for smartphones that farmers can use to take pictures from their crop, to identify what weeds do we have on the field, is there disease, or what kind of disease does my crop have, what kind of insects do I have on my field. So the farmers get the added value that he knows what is going on the field, and maybe also what products do I use, or do I have to, what do I have to do to cope with that problem. Bayer has the advantage that we get all the data from the fields worldwide, and we can see when there's a disease coming up and spreading. We can see if there are insects popping up and spreading. So we can adjust our forecast using that data and be on the market at the right time with the right products. And that is Industry 4.0.
Sorry, and this is a big one, and I kind of forgot. RPA, robotic process automation. I don't know if you're familiar with it, but it's basically another way of integrating systems, which you integrated with the front end. So it's basically, at the most simplest level, is a script that actually moves the mouse, clicks at the right place, and types everything in. To actually make that work, you need natural language and processing in a lot of cases to be able to read in invoices or files that are coming in, extract the right information and push it in. And primarily you use it because this is unstructured data that it's moving in so that you convert it into something. So this is one of the things, I mean, this is actually going to be replacing a lot of people's jobs, mostly because you're actually, it's people that just do a mechanical job that just read this document, type it into SAP. That is another, I think, a very large component of the application of AI/ML.
Next question.
For Manuel, I was interested with one of your work functions on your bio about strategic alignment innovation with supply chain, if I'm correct with how I read that. Can you share some details in that space? Because these things are questions within our organization about innovating and would aspects of simulation 4.0. Where does that fit with the innovation space? If that makes sense.
I didn't get the question correct. Could you repeat that again?
So in your bio, I believe that there was something what you're doing with Bayer with innovation, and was it strategy or strategic?
Yeah.
And I just wanted to know more about, if you can share some information about what is that and what do you see in this?
Okay. It's about finding answers to the question, what kind of tools do we need in the future to resolve the problems we have today and the problems we will have in 5 or in 10 years to resolve. So we have first to identify what are the questions that are important for us for the future, and to find an answer to that. How can we support that with computer-based methods in general? So simulation, scheduling, whatever. That's the idea.
Okay, thank you. Let me share one thing, and then I will ask my question. The first thing is, what's happening in the AI, or artificial intelligence? Previously, you need to be scientists, right, to use some experiment in the AI platform. But now, if you have an access to any cloud platform and have an artificial intelligence algorithm there, you can put your data and you can get the results. I think accessibility is one of the biggest game changer here. The second thing that, what we see now, we can see some correlation between different variables much easier and much clearly, right? Previously, when you look at even the manufacturing is a very complex operation, right? Millions of different type of signals are coming together. Now, when we have the data, even it is not so clean, but if we know that which data stream is coming from which type of variable, we can see some correlations that we didn't see it before, right? It is a very, it is the power or why everybody is interested now in a corporate level, right? Now it is not anymore a scientific topic, but it is a very practical operational topic. But it's good, right? Maybe my question is, I am not too much familiar with this Simio architecture or something. The question is, do we need to worry about the cyber security if we are using the Simio in a cloud platform? Is it something that normal and we don't need to worry, or do we need to worry about it? Yeah.
Okay, I was recently on a conference on chemical process simulation, and there was the same question. So do we have to bother with cybersecurity? And the answer from the conference participants was, well, actually, the cloud is probably more secure than your intranet. Yeah. So it's a question, do we really increase the level of insecurity by going to the cloud if the own intranet is not 100% secure?
I think we believe that we are more secure.
cybersecurity is a huge issue. I'm just going to share one example of a company that I was working with. They got hacked by somebody out of the Ukraine. And this is a very large company. They basically were without a system for 3 months. And this is a global CPG company, one of their divisions. They just had nothing. So we got in 8 months later to do a supply chain planning project. And basically, their data, we had to extract 3 months and say that data's garbage, just because it just didn't work. And it came in because somebody opened up an email and it just completely infected their system. So it's going on to what he's saying is you're assuming that your network is secure. It wasn't. This wasn't a cloud. This was directly their system itself. It's somebody that they actually invested in cybersecurity before it. The cloud is vulnerable, yes, but I wouldn't necessarily say it's more vulnerable, and I agree. In a lot of cases, it could even be more secure. They decided to try to push stuff into the cloud as well to have redundancy backups and not maintain it. But basically, I mean, just imagine their ERP was down, like that level of production. Chaos.
Just to complement, to complete, there is also the possibility to have an in-house cloud, right? Your company can set up, if you have really very sensitive data, you don't want to get into the public cloud, you can have it in-house in your own cloud.
Yeah, so I kind of have a more general question about the implementation costs and ROI of, really implementing a true end-to-end system to get something that might be more at the industry 3.0 level to industry 4.0. So kind of my mind, just based on my experience with the neural network and understanding a very complex manufacturing environment, huge supply chain, I actually think that smaller companies might have an advantage. Maybe they're more cash strapped, but it might be easier to implement this type of system to really kind of accelerate their individual business. So is there any success stories that you guys can share as far as, length of time to implement, kind of rate or compare the different sizes of the companies?
I'll take a start at it. I think the number one factor, as it's been mentioned by others, is data. Is there an MES in place? The ERP system is in place? And how clean is the data? Even though people think they have the data, when you try to bring it together, they don't, plug the data together, they don't match up, they don't line up. We've had several projects that we start, and the first thing that happens is there's a data problem. And so I think the companies that have an advantage and will have much easier time bringing this in are people whose data is in good shape.
If I can add to that, people think the data is in good shape, right? Then you get there and they say, we have SAP top to bottom, whatever the case might be, and I'm not blaming any system here, right? Because it's not the system is just a repository. And then you say, okay, show me your ERP. And you look at, they have identified their equipment to a work center level. Great, you go to the MES, they've got an MES. Go to the MES, that's to an equipment level. But that doesn't show anything about the secondary resources, operators, tooling, and so forth. You then ask the question, so where is that? Oh no, the planner has it here on his Excel, right? And then you look at the MES data and you say, well, there's the fields for setup, for changeover, but there's no data in there. So suddenly this good data now becomes a problem, right? Because you must now decide to what level of detail do you want to do it, and what is the velocity at which the data is going to be available. Because, yes, real-time planning, fantastic. To what level do you have the data and what is the velocity at which you can. If you can only give me the data once a day, that's the fastest we can replan, right? We can't do any fast. So there's a lot of these constraints about the level of detail, the speed of data, and the speed of replan, right? To get to real time is a different ball game. So that's where a lot of the work lies. So you mentioned the small versus the small companies typically lack the systems, right? Because they operate, we went to a company the other day, they ran SAP on AS400, right? I didn't think it was still possible, but they run SAP on AS400. No MES, we're stuck, right? What do? Well, we can build it in a spreadsheet or a custom database, but it's no good, right? Because within a month or two, you add a new item, then your sheet is behind. So the challenges are on the data. Usually the larger companies has got the most to gain to stay ahead in the game. They usually have the better systems, and they usually have the IT teams or their own internal SAP staff and so forth to run. We visited a company last week that says, oh my goodness, we don't have the routings per item, per machine level. But we scan things in for years where things go. We're going to run some AI on all of the scans and see if we can generate the routes from those scanned data, right? So, but the smaller companies just can't do that, right? So, but it's a tough one. It's a good question.
Even when people have all the right data fields, the right systems in place that collect all the data, it's never been pulled together and used, all at the same time. So there's misreferences. There's references to things that aren't over here. They're called one thing in one place and a different, label in someplace else. So it's until you plug all this together and try to create the digital twin that you really find out what issues you have with your data.
So we've worked with companies in the $100 million revenue range and in the $1 billion revenue range, $1 billion plus. There's a significant difference. When you're talking about, and I'm not going to talk about $20 million because they're just trying to get their ERP in place. When you get to the 100 millions, they have an ERP in place, but they struggle even to actually implement an improved demand planning solution or implement a WMS system or a TMS, just because the cost to ROI of it is just not there. So, and even without these building blocks, it's really hard for them to try to, the benefit of actually having a simulation and being able to plan it is a lot lower than, for example, if you can improve your forecast accuracy by 15 points. And they don't have the budget to actually improve the forecast accuracy by 15 points. And it's, in a lot of cases, it is possible that their Excel schedule probably gets them to a 90% solution because it's not that complex. While in the $1 billion ranges, you already have a bunch of these systems implemented, especially if you start getting to the $5 billion or $10 billion in sales. They're just disparate. And that's where a lot of this value gets unlocked.
Thank you. I think what has also created the fertile ground for Industry 4.0 is this whole notion of we're going to have a full configurable item to an order quantity of 1. The marketing folks say that we are so flexible, we can take any order quantity and the customer can configure any color, size, length, volume. That's fantastic, right? But if you turn around and you look at the factory, they say, oh, how do we do that, right? And that's where Industry 4.0 comes in, because factories and the people making the decisions simply cannot respond to it. And as you said, as complexity improves, the whole thing just comes tumbling down. So the need is also bigger at the larger companies than at the smaller companies. A last question or two?
So has that been implemented at a large company? Digital process?
All your supplier side and everything.
So from a Simio perspective, no, because the catch is until you have control of the factory, right? So you can plan the supply chain all you want. If the factory cannot deliver, the supply chain will always fail. So up to now, the biggest issue is the factories. Okay, having a digital twin in the factory. So from a Simio perspective, that's our focus right now. So we have some customers and some large pilots on the factory level. Now the beauty is, from a deployment perspective, the work goes into factory number one. So if you have 30 factories making the same thing, although the configuration is different, if you build a data-generated model and you predefine the objects for that factory, then you go with your cable to factory number 2 and you plug it in, giving that they have standardized their data across that, and you have a 80% model out of the box, right? So to then replicate becomes really, really powerful, but to get to the data level, detail and accuracy, for the first model where you develop the objects that are created and driven by data, that's the hard part. When you solve that, you go, right? But yes, it is a process, and data is the issue.
This is for all the panel members. One of the issues we have is our disposition and rework has almost infinite amount of rework or possibilities or rerouting, and we don't really have a lot of quality or a lot of historical data to some of these are new products. So my question is, has simulation been used to predict like accurate workaround plans or the routing? I just want to hear some maybe success stories or ways that simulation could be used.
So I can't talk about success stories, but I can talk about the question from more of an academic perspective in the application of simulation. Basically, if you have an infinite number of routings and you don't have any historical data, you're just guessing on what those routings are going to be. So you can make a guess. Simulation can analyze what the results of that would be, but in order to do any decision making or optimization, you have to have some direction. Or you have to do an experimental design where you look at a number of different alternatives, and then as you collect data, that's going to put you on a trajectory towards the answer. But the basic question is, if you don't have data, if you don't understand the probabilities of different routings, simulation is not going to help you answer that question.
So we've actually worked in a different same type of situation, just not in terms of routing, and it's through expert interviews. We have sat down with a variety of different experts to try to get a sense of what it is, and then we actually validate their capacity to actually, how good their guesses are. So the more experts you end up having, the better you're actually able to guess. We actually, one of the more interesting ones that we've did it is we worked with a racing team to try to get a sense of they do new tracks each time, so how many overtakes they could actually take, which is very significant so that when they're actually doing their planning. And there was no way to actually do it except to actually sit with the racing technicians and actually say, hey, rank this track, rank this track, rank this track, and then we've actually done a regression to actually get a sense of what's the sense of what it is. We also do it a lot with NPI products. When you have a new product, it's all guessing to see how much you're actually going to be able to redo it. The same way with another company is pricing. They do individual contract pricing associated with it whenever then a new customer comes in. And it's why did you price it this way? And then we've actually done it with a bunch of different people. And then you just try to get the averages. So you drop off the useless ones, and then you actually focus on the ones who actually get the best guesses. So that gives you some, that approach and methodology can give you some insights of what's the likelihood of the routing that actually ends up happening. But it's purely based on your ability to extract people's experience and turn it into numbers, which is not easy at all.
But, one of the things we added, I think 2 years ago to Simio is the ability to look at the sensitivity of the inputs to the KPIs that you're measuring on output. So, kind of combining with what Jeff said, and Sebastian talked about using expert opinion, and eventually as you get data, it's going to get better and better. But what this will tell you is where you can spend your time and effort getting better data. Because some of the inputs may matter a lot, and some of them may not. And so this will tell you which ones are important to get right.
Final question. Any more? I'm just going to close out with a few final thoughts here, just to bring us all down to ground zero. This artificial intelligence rules, it's fantastic stuff, but let's just look at this. The reality today is we've got a bunch of current systems in place, right? And these are just examples. You've got an ERP, you've got an MES, you've got some robotics, AGVs, VGVs, smart glass equipment, and I've just got the opposite view of Louise. He said Excel is the biggest enemy. I think it's one of the greatest inventions, right? Because I don't think anything can work without Excel. But I know where he's coming from, right? So the issue we find is very few places, even large companies, have these systems in place, right? Now, I've heard the notion that if Industry 4.0 becomes the thing, that some people are going to fast track through this 3.0, right? Because now there's an incentive to put all this stuff in place and plug things in and make it work, right? So some people might just blast through 3.0 and think it's part of 4.0, right? But the issue is this is still 3.0, and some people just have an ERP and that's it, an Excel, right? And large, I mean, you cannot even believe that such large organizations function like that, but they sort of make a profit in spite of themselves in some cases. And I'm saying this in the best possible way, right? Now we say, all right, so now we want to enable our smart factory. There's our systems, so what do? If we listen to Forbes say we're going to connect all these computers. Okay, well, that seems like an idea. Let's integrate all of these things. Let's connect them. Off we go. Now, what I like to do is I like to be the fly on the wall that listens. So what are these computers saying to one another? Okay, because I'm sure the ERP is in French, right? The MES is German. The Excel is Japanese. I can't see how they can speak to one another, right? Now, so this leaves a big question. How do we solve that? That came out as part of the discussion. So as a final thought, let's assume we fix all of that. We fix the data, we get the same detail, and they all speak English, right? Great, now they can speak. What do we get now? Tons and tons of data. It's a pipeline of data that we get coming to us. So what can we do with the data? So let's say there's time now. So most people in this room would understand time now, right? Almost all the data that sits in our Industry 3.0 systems is what? It's historic in nature, right? Example, MES. It can give us things like what is our current OEE? What is the current WIP in the system? What is my resource availability? All things that you need to know, as Louise said, to start up the model, right? You need to know those things. From an ERP perspective, we know that we make our targets yesterday, yes or no. And what is our current demand and what is our current service level, just as an example. But what does that do for us for Industry 4.0? Absolutely nothing. That's the issue. So what do we need? We need something that does what? That looks forward in time. That we can look at alternatives. We can predict future performance. Because what happens, marketing comes and says, guess what? We've got this new product that we want to add. Or we want to put in this new machine. We want to do all of this. You have no idea what's going to happen. So and here's the 30-second commercial, right? So that's where the digital twin fits, right? Because what it will do, it will sit there, it will take the information, it will mirror your data, help you with that process, it will run forward in time, It will generate the schedule or the dispatch list that gets sent to the machine level, the operator with his smart glass or Google Glass, the AGV, the robot for execution. And it can do so again and again. It can sit as a black box behind the system. We have some systems fully automated where nobody even looks at Simio, right? It sits behind every 3 to 5 minutes based on certain trigger events. It will call Simio. Simio will take a new snapshot, run the simulation, and give new outputs, keeping the whole automation process in sync. That's it from my side. Thank you very much. Thank you to the panel. It's always risky to be on the panel because anybody can ask you anything, right? So thank you very much.